So far in our hands-on or while writing the codes, you have seen that I've got a lot of errors, which is pretty normal. While writing a code, definitely you will get errors. And even if you fix everything, there can be edge cases that you still get error in production or any other environment. We need to handle those errors pretty gracefully. It should not be the case that the program is completely shut down or the program has corrupted something else. That's where error handling modules in Python become very useful to handle the errors. In fact, there's only one module in error handling, and we'll talk about that. So how do you handle errors? We have to handle errors gracefully. That is one of the things. And the only way that you can handle error is try except else statement. So what is this statement? So far we have run a lot of code blocks, right? So we have run if statement, we have run methods, we have created functions, and then we put program logic inside of those methods, functions, etc. So you keep on doing that, and whenever you are performing any action, the same code, you execute the same code and write the same code, but just before that code you put a try block or try except block, and the syntax is like this. So the code block that you were writing or you are supposed to write, you have to write that, but write that inside of a try statement. Now what would happen is Python would execute this program or execute this block of code, and if it is fine, then it's okay. If there's some error, Python would throw that error in the except statement, and here we can mention the code block to handle errors. So if something goes wrong in this particular program or in these statements in the normal code block, that error can be handled. Python would know that the error, there has been certain error, but instead of breaking the program down or instead of throwing some ugly statements, you can handle it using this except statement, and whatever you write here, that would be thrown. And if everything goes right, then you write some code block that everything was done and there were no error. We can also use raise statement to raise our own error, wherein we use command like this raise statement followed by the exception, and if needed we can pass data also. And these are the built-in exceptions that Python provide. There's attribute error, floating point error, import index error, import error, key error, memory error, so on and so forth. Just to give an example, index error would be created when you have a list or a set or a tuple and you're trying to access an element which is beyond the length of the index, length of the set or length of the tuple. That's when you'll see errors. Let me show you some of the errors and ways to handle errors. So I have created this particular program, IAM underscore error underscore handling. And I'll not write very heavy duty code. What I'm going to do is that I'll be defining a function and I'll be defining a variable, let's say a list variable or a tuple variable, etc. And then we'll catch the exception and we'll show that in a graceful manner. So first let us define function calculate final price, which takes amount and a discount. Now obviously self would not come because this is a function, not a method. So the final price or the final amount would be equal to amount minus amount into discount divided by 100, and let me return the final amount. This is a very simple function, and I want to call this function calculate final price. I'm supposed to send amount and discount, but I'll not do that. Instead I will use this inside of the try block. So it means that I am executing this code and I'll have to get it in a variable. So I'm executing this code. I'm not sending any statement here. So after that I will type except, and let me type that you'll have to pass argument to the function. So it is the same block of code that we had executed earlier also. Now if I execute it by itself, let's see what happens. Of course it will give error, and let me comment all these. And if I execute, this is the error that you get. It is a type error. It says that calculate final price missing two required positional arguments, which is correct. but I'll not use this. Instead of this, I'll execute the same statement inside of a try and except block. So I'll execute this, and then instead of this kind of ugly error, it will show me that you'll have to pass argument to the function. So as you can see, it says that you'll have to pass argument to the function. Of course, you can put error here with some, exclamation marks, and then it says error, you'll have to pass argument to the function. And you can print it in all other colors also if you want. Of course, that is not needed. Now, instead of failing the program, it is showing you this error. Or here, let's say if this fails, maybe you want to execute some other function if it fails out. So let's say if I execute send message, and I'll define this particular function send message. I do not need any argument here. Right now I'm just printing. So I'm just printing run the program again, but if you want, you can send or execute some other block of code also if something of this sort happens. Now, what do you want to execute? Of course, that would depend on what you are running the program for. But now if I execute this, it is saying run the program again. So this is a graceful shutdown. It is not that the program has completely ended, or for that matter, if you have a proper function defined which will execute when there's some error, then that is much better handling of error. Now, one more thing is that this is a single block of code, right? I know that I'm executing this function, and I know that the error that I've got is you'll have to pass the argument to the function. What if you do not know? So let's say you do not know what error you are getting. So how do you handle that? You can use exception as something like message. So now what would happen? The error that was received, put in exception, and that message will be moved to the MSG variable, and I can print MSG, and now it will see exactly what error that you have got. So instead of writing your own error, you can use this exception as message, and then you can show the message and then execute the program, some other function also. So this is a better option of handling errors. But let's say there is some other kind of error that you want to make sure if that error happens, which is very, very critical, then your entire program must fail. And that kind of failure is not provided by Python. What would you do? So let's take an example. So I'll initialize x with 10. For this program to execute, for the business to run, let's say the value of x is very, very critical. And value of x should always be greater than 10, because that's a business logic. It has nothing to do with Python data type or anything. That's a logic that you want to build, that if value of x is less than 10, then it's a very major problem in your program and it should not happen. In fact, it's such a major problem that you want to fail the entire program. You want to shut down the entire program. So what you can do, of course, you can have this if statement, if x is less than equal to 10, then what you do, you maybe raise an exception. And here you can mention raise, let's say something called value error, and provide a message. So now if I execute this, this is how it will actually raise an ugly error saying that it's a value error, x cannot be less than 10. And this is what you want maybe. Now this kind of error will not be there in Python, because let's say there is the value of a variable, let's say var equal to 1 to a, and if I convert it to integer, what will I do? I'll use the int function and var. So now you know that it's a problem, but it's an internal Python problem. So you can use exception as maybe a, print a, which is fine. Now this is a Python related problem. Now if I execute this, it will give an error saying that invalid literal for int with base 10 1 to a. This is a Python problem, but this is maybe a business logic, and you want to print something ugly because it is so critical for your business that you should not allow the program to run, and you should everyone know that this is a problem. So you can use this raise with value error and pass some comment here or maybe some other messages, and it will fail like this. So that is one of the use cases of raise. And now there's one more use case. So here, let's say you do not want to capture it in exception and you want to put, let's say, put raise here. Now what would happen? The actual value error would be raised. So it says invalid literal, so on and so forth. So if you are using the raise statement by itself without any value error or any data, then it has to be used inside of an except block. Otherwise, you can use something like value error and pass a data so that it is shown in your error logs. So that's all about this particular section. Let's summarize whatever we have discussed, and I think it was a pretty big section. We started off with class object. I talked about what a class is, which is basically a blueprint or template to create objects. And what are objects? Objects are nothing but the instance of a class or a variable of type class that we define. And whenever we define functions inside of a class, those are called methods. And to execute a method, along with passing other arguments, we'll have to pass something called a self argument also, which contains the pointer to the memory location where the object has been created, and that has to be passed. Then we talked about init function, or init method rather, which automatically gets executed whenever we initialize an object using a class. Then we talked about inheritance. So we can create class from another class, and all the properties of the base class or the parent class would be copied over to the child class. And you can have additional members in the child class also, meaning we can have additional variables and additional methods in the child class. Then I showed you how memory management in Python works, the heap area, the stack area, etc. Then I talked about modules and packages, and modules are essentially used to break code into multiple pieces and call them separately so that multiple other codes can use the already built-in function which is there in a particular module. And package is basically putting multiple modules in a folder and call that a package. Then we talked about name and main. So you can execute a particular module in a standalone manner also, in such a way that the program or the module can run by itself, or it can be run by in other program also by importing the module. So to do that, we use the name function underscore name underscore variable, and if it is main, that means the module is getting executed in a standalone manner. Then I talked about namespaces, which is nothing but a logical grouping of all the functions, methods, variables, classes, etc. of a program. And if we use the import statement, just the import statement to import a module, that particular module would be loaded in its own namespace. So I'll have to use the module name all the time, or its alias, whenever we use any function or method from that particular module. If we use from statement, from module name import either functions or classes, then those modules or those functions and classes and variables, etc., are loaded to the current program's namespace, and we do not have to append them with the module name. Finally, I showed you error handling using the try except block, and you can raise your own exception also using the raise statement. That's all about section 3. Thanks for tuning in.